If you want to learn, like I have this year, how to produce a multi-phase harness that is capable of self-improving and producing pull requests that meet adequate standards for human review and can self-improve from human review, listen in. So I've I've been working on this in 2026. It has been all consuming. It keeps me up at night, but and it's been a long time before I felt like it would get to a point recently where I am seeing it produce work along with other people using it that is meeting good standards for human review. So I want to share that journey with you. And I also just want to say, even though it might get technical, you can produce everything that I'm talking about with human language. Uh, you should have an understanding of the systems that you're making. If you don't understand them, you should use your harness to try to understand them. It is important. You cannot let the understanding of the system get away from you, but you can produce the whole system with human language. So, where did I start? I started with a basic agent harness with a bunch of skills from Matt Pocock. I used some of his skills like write a PRD, grill me, the two issues skills, and sandcastle. And that gives you a really basic foundation that you can use as I guess, the basis for your meta harness, something that can actually improve itself through its own version control mechanism, its own tasks that it might create for itself. So I, when I make, when I play with these harnesses, I want a harness that's quite general. I use the same harness for all of my projects. There might be a case where that's not true one day, but it's true for now. So I start with a projects folder. I have the harness live in that projects folder, and all of my projects and the Git work trees live under there. And this is all part of a repo that I will share in time. But the idea is that the harness should have access to any project and any branch that it wants to work on, and it should have the capability to run on any of those things in parallel. So the structure is important. I don't have a separate harness per project, and I try to have as little in my home directory as possible. But from that point, I want to take that harness, and I want to be able to produce something that is able to go through rigorous phases of creating a task for itself that is rigorously structured, and we'll go into that. It should hand off that task to something like a test writer, which then also passes off its results to an implementer, which is doing the grunt work. Then finally, the validator is checking that the tests that the test writer initially wrote, which were initially read, are passing. And then finally, a review phase, which is unlike the validator, which is doing something more like it is pretty much a binary result as to whether or not any of those tests are passing. The reviewer is doing something that is more qualitative than quantitative. It is checking things against the original brief, checking, is it possible that there was extra assessment acceptance criteria needed in that brief in order to improve the result? Are there code standards that are being violated? Both the implementer and the reviewer need to have access to what your code standards are, and those are all improved through feedback with code review. So if when something gets to code review, and various reviewers or agents might be chiming in, at the moment I use only humans are chiming in on code review. We then will inquire with the harness what in the harness needs to be changed to incorporate that feedback. And I suppose, so that's the big picture. That's what the 4-phase harness looks like. 4 phases does seem to be the sweet spot at the moment. I used to have more. It didn't look like I was actually benefiting that much from it. And the other thing that's interesting about this harness is that the implementer and the reviewer are using the same model. And I know that there are some older studies that have said that that's not a good idea, but in 2026, there are studies that show that it is actually a good idea, provided you are clearing the context for the reviewer. So the reviewer is really only getting, it's not having a direct line of communication with the implementer. The implementer doesn't really get to say anything to the reviewer other than the code and the structured handoff that is allowed. So the reviewer doesn't really get to be poisoned by previous context. And the studies do show that that is actually superior to having a separate review model. The other benefit that we get by actually getting that to work is you don't chew up failed cycles, because you don't really want your reviewer to have information that your implementer doesn't have. Otherwise, you're just wasting a cycle. You're guaranteed that that implementer isn't going to know everything it needs to do the task. So that's the big picture view of like how the 4-agent harness works. And again, all of this can be built from a basic harness that can just self-improve, like the one that I mentioned. And the goal I have is that I want that task that is at the front of the pipeline to have front-loaded as much of the human-in-the-loop type requirements as possible, so that when we fire it at the harness, it's left to run. And then we can also have a dependency chain. We can actually stack up multiple issues procedurally that can merge themselves to a temporary branch. And we can run through all of these issues multiple times per day and have them integrated and tested together multiple times per day. So I think that one of the other things that I was missing early on is this change in the way my brain works when it comes to alignment. And it's changed the way that I communicate with these agent harnesses. I've learned that if I tell an agent harness to do something, that's often a really bad idea, unless I'm really sure that it's the right direction. And often I will find that direction through inquiry. So, I think of alignment as finding a center of gravity, and to find what it represents is a midpoint on what my intent is, what the agent knows, perhaps what research is out there, what best practices are, also what tests are and what kind of tests we should have. All of these sorts of things are what anchor the harness to reality. And so when I formulate an issue, I use a skill like Matt Pocock's Grill Me, which is a wonderfully simple skill. All it does is it gets the agent to essentially question you relentlessly about any possible decision in the tree of possible decisions that it can see it might have to figure out for this task. And what wasn't clear to me initially when I started using that was just how open-ended those conversations could be, that I now find alignment to create a task through more like a stream of consciousness. It's like sharing my train of thought. And I don't have to worry too much about making mistakes or changing my mind. A good model at the moment I'm using Claude, but everything I'm talking about today is generic. It will translate to other models. When I talk with it, I will not just be answering the questions that it asks of me. I might also say whimsically, oh, by the way, that makes me realize that if we do this, this could be a risk. I'd like to come back to that, or can we explore this first before we come back to your question? So I will interrupt the flow. And when I'm initially creating a brief, like writing a product requirements document, another skill that Matt Pocock has shared, you can basically take it as an opportunity to share as much as you can possibly imagine with this task, including all your fears, all your intuitions about what might work, what might not work. I also encourage it to do research. That's another form of grounding. You know, if we're getting into an area that I know nothing about, or if I'm getting asked questions about things I don't know anything about, that's the point where I'll go into question mode. I'll get it to things down for me until I understand. Get it to research best practices, come back to me with recommendations. Another thing that I will do is I use a steelman skill, which I wrote, which is quite basic, but the steelman skill basically gets it to steelman the possible choices and strengthens the arguments for each one, and then comes to me with, you know, what it would recommend. And I also find that really, really helpful for me to make better decisions. So when you're in this mode, initially you might be tempted to let it go with the recommendation. That is a bad idea. You're welcome to do it. You'll probably learn, just like I did, that it's a bad idea, because you'll find yourself in a scenario where you've built something you don't understand. And you're going to have to understand it anyway. You're going to have to backtrack and perhaps undo some of the decisions that have been made. So it is really, really true that you don't get to outsource your understanding, as has been shared around on Twitter. So I think that gives you a pretty good idea about what I do when it comes to front-loading alignment. It should be a discovery phase, and I try to go into an alignment phase with trying to figure out how I ask the model the right questions, so that it can arrive in an answer that also feels right to me, rather than me telling it what to do. And there won't necessarily be perfection there. It's just that when the model arrives there through inquiry, through co-inquiry, then you're at least on a good foundation for the beginning of the task. It does not mean that you'll have bulletproof code. It just means that your intent at this point is quite likely very clearly defined. And so long as you're thorough, a plan that gets written at this point is probably very accurate. You'll probably not have to correct very much in the plan, unless you had more questions or you already knew you needed to do more work to clarify the plan. But you'll probably find that if you go through this process, you will have excellent plans. And that actually represents what a task would be that we would feed into this harness. So I think that settles alignment. It's center of gravity. It's a center of gravity that we find between ourselves, our own intent, our own knowledge, the model's general knowledge. You know, it comes with a bunch of general knowledge, but nothing to anchor it to reality. Getting it to research, and also looking to tests. And that is the other thing that we do with alignment. So I modify any skill that's making a task, like the two issues skill that Matt Pocock has. I also get it to front load what a good test looks like, because what you'll find is that if agents are left to their own devices, not only will you get bad tests designed from the beginning, at any point in the chain you'll get hallucinations, hallucinated passes, you will get mock tests that are actually useless. The test infrastructure is the thing that needs to get locked down. So one part of that, though, is getting alignment on what a good test looks like. So, in the case of software that I use every day, which is Houdini, I want my tests to actually use something like Python and actually go through the same API call that a human would if they were clicking on some menu function. Agents are not very good at doing that. If there is anything in the infrastructure that stops them from running Python or whatever, they'll make up some mock test and they'll self-proclaim we're all good here. And getting your test, getting your tests to behave in the harness really is a process of pulling as much of it away from the agents as possible. It needs to become like deterministic hooks that are executed in between steps without any option. So you'll find that as you go through that process, you need to inquire exactly what's going on with those tests. The harness will lie to you. You will see tests pass, like I did the other day, probably on the 10th iteration of like getting these tests down. You'll see tests pass and think, we did it. Did we submit a job to the compute farm? And it will say yes. And I'll say, fine, give me a job ID. And then it will realize, oh, sorry, I didn't actually do that because the test was an integration test. And integration tests aren't run because they're too slow. I'm like, okay, I guess back to step one then. If you give your agents any option with tests, they're just going to take the easy route. And so, this is an example of why your tests, they do need to be locked down. You probably don't have the ability to give agents options, and you need hard gates to detect what tests are expected. So I think probably the next thing I want to go into is what is it that will make a multi-phase harness successful? And I think the first principle that's really important is that no agent can validate its own work. So we can't, this is why we might have something like the issue that is created with a general agent at the top level. It's just your normal Claude session, basically, that is aware of how to create some task and what that looks like and how it's formatted. And it will specify what are the files you're allowed to touch and, what are the acceptance criteria that we expect to see. And so when something like, if you were to just give that to an agent and say, write the test and do the work, there's nothing to stop it from faking its own tests, skipping tests entirely, modifying tests as it goes. So we need to front load the test phase in front of everything else. So we write red tests first. We have our acceptance criteria, which you don't necessarily need to think about every single one of them. Claude can help you formulate those, but you should have a concept about what some of them are. And the acceptance criteria will go into the test writer, and it's the test writer's job to produce a test for each one of those acceptance criteria. That's its only job. It doesn't care. It actually doesn't want them to pass. They should be actually initially red tests. It has no other job beyond that. So once it's done and they're committed into the chain, then the implementer gets to come along. And the implementer is not allowed to modify the test. And if it tries, the validator is going to catch it. So there's nothing to stop the implementer from modifying that test, maybe not committing it, thinking that it's green, and saying I'm done here, but it's not. And it will actually do that. I've seen that. I've seen it try that multiple times, and that's why you need the validator to catch it. So it's the implementer's job to not change the tests. It's not allowed to commit changes for the tests. It's only meant to do the work, touch the files that the workload says it's allowed to touch. It's allowed to make requests to touch other files with the reviewer, but there's constraints on that. And once we've got a little turkey over there, don't know if you can see it, but anyway. So once you have the implementer that has satisfied the code generation requirements and that the test pass, it's then the validator's job to quantitatively say pass or fail for every one of those tests. And that is the only job the validator has. If those tests fail, it will send the implementer back through the loop again, up to 3 times does the implementer. It's an arbitrary number, it can be changed, but that's what I currently use. 3 times is what the implementer gets to do. And then once the validator is all green, then we go to the reviewer. And the reviewer is checking that the implementer has passed, obviously, but it's also looking at qualitative analysis. So it's going through however its context says it should, to review the original brief, make sure that the acceptance criteria are met, make sure that there are high-level principles that you might have to in your code standards or how you design things in your code base, make sure that those principles are adhered to. Perhaps even raise opportunities to make something dry, which is a tricky one, deciding when something should be dry or not, but it's subjective and, up to how you want to run that. But the reviewer gets to look at things from a bigger picture, check that the code standards are being adhered to, check that any of the principles that you've caught through other previous human reviews and have integrated into the context are being managed properly. And then it will either pass or fail, and a fail will allow up to 1 revise loop. It's an arbitrary number. There's nothing to stop you from having more than that. But these revise loops are pretty expensive at this point, because one of those loops then gives an implementer another 3 goes. So at the moment, if I see that happen more than 1 failure at the revise phase, I want to know about it. I want to keep tabs on this harness. I want to have visibility on every phase whenever something goes wrong, to see if there's opportunities for improvement. And I want as much taken away from these non-deterministic agents as possible. I want, like Dex Horthy says, I want deterministic glue keeping all this together, so that the agents are sprinkled in at the area where we want the smart stuff to happen. And I suppose the other thing that I didn't address is that I am yet to see a solution where you can talk to an agent and get it to write a test and be guaranteed that it will use the type of testing requirements that you want to see. You do need to make sure that these tests are being run to your standards, and you will also need to put hard gates in that, for example, if I mention this piece of software in an issue, I want to see that the test is actually launching the software. That might be an example of how we would have a hard gate, something that an agent cannot escape. It must open the software and it must call the function that we intend to write to test it. So I think that's a pretty good picture of how that four-phase harness can actually produce output. Once the review agent says we're all good, we have a merge request or a pull request that humans can look at, and we can also take the feedback from that code review to basically get the harness to even file issues against itself or to alter the original issue. So if we are seeing high-level problems, like another common test issue that you'll see is that a test writer will write mock tests, or the other day one of our human reviewers caught that it was using an AST import to just check that actual string was in the test instead of actually testing the behavior. So, that's the kind of thing where we'll take that human review and we'll feed it back into the harness itself to mitigate against the problem. So the harness could file its own issue against itself, run the issue on itself, and then run another test on the original issue to see if the comment had been dealt with. Once you kind of have all of that in order, there's nothing to stop you being able to run multiple issues in parallel, or also run multiple issues as a procedural stack. And this is the part that really excites me, because for a long time with AI code generation, there are times when I want to be there tweaking and tuning, and then there's the end of the day and I want to be able to go run everything to the best of your ability. And so what this workflow can do is it can take a huge stack of issues. You might have a giant product requirements document that could represent months and months of work. And you could have this stack of issues, and provided you have front-loaded all of the unknown quantities and all of that alignment has been done with all of these issues, you won't get it right on the first shot with anything complicated. But it won't take too many iterations to remove those unknown quantities. And instead of those issues getting merged directly to, say, the feature branch that represents when the work is done, or being merged to a mainline, when we do an AFK run, we are instead merging that code to a temporary branch that represents a temporary run, because it's essentially ephemeral data. We don't have to care about it. It is cheap, relatively speaking. I mean, not necessarily cheap in tokens, but it's not involving wasted human labor if it's determined to be throwaway work. So an AFK run allows us to say, I'm done for the day. I want you to basically run all these issues through the graph to the best of your ability. And and when you're done, we're going to have this feature branch that represents all of the integrated work. And I think the thing that excites me the most, like one of the most exciting things about this workflow, is that before I had it, this tenacious nature of working with these agents, you can just generate huge amounts of code to the point where it's unreviewable. And this actually makes huge amounts of work highly digestible by human reviewers, because each issue has its own merge request, and you see the history. So you can actually do retroactive code review through each issue and see where it faltered. You can integrate your human feedback into where either the issue was not defined accurately enough, or where there might be a harness failure, and then you can essentially integrate all of that again and then do another run. So yeah, that's a really wild thing to see, when you can actually leave that much work alone, unattended, and actually see the full integrated result in sometimes a couple of hours or the next day. And I think that this workflow has been really exciting. It's amazing how quickly it's been coming along. That it was all more or less built with human language, but still with still an understanding of architecture and engineering principles, and having other people involved in seeing that work. And I hope this is useful to you guys out there. I'm sure it'll be out of date in a couple of weeks.